So delete nth node from the last in linked list. So this is really very famous question, and I will discuss two different solutions for this. First will be like intuition behind the thinking, like what is this problem and how generally people think or start thinking about this, but what is the best solution. So in order to understand this, so this is your head and this is passed to your function, and then you are asked to give or delete the last, the nth node from the last. So let's say if your function is this and we have passed head and n we are passing, this n can be like 1 2 3 4 depending on the size of the linked list. But the point is, if I'm giving 1, meaning I'm giving you delete this. If I'm saying 2, then I'm asking delete this. So basically if I'm saying delete 2, then the final linked list should look something like this, here and here. Okay, 1 2 3 4 is deleted and we have 5, and I will return this head. If I'm telling you delete 5, if this is 5, then in that case 5 from behind is 1 2 3 4 5. So I want to delete this. So basically then I want to return this, because 2 3 4 5 would be the remaining numbers. And if I say 3, then I will delete this. So this connection will now go here. So this is deleted. So basically I have to say that if this is subpointer p, then p's next is going to be p's next next. You got the point? Because p's next is, this is a node and it will have this next area here, right? So we are saying that p's next, so this is p's next is going to be p's next. So currently this is p's next and p's next is this. So that's why we are saying we will have this connection now. So now as you have understood this, so let's think about the solution, like what generally people would think. So basically what they can think is, the challenge is actually you don't know the length because that's not provided. You just know that this is your head and you have been given some number to delete, but you don't know like what is the length. So what generally people would think that, okay, in one loop I will traverse the whole length and then I will know the number. That's great. So let's say if you traverse this whole, like from p, if you keep on incrementing saying that p is equal to p's next and then keep on counting, then by this node your count will be 5. So you know that total length is 5. And then let's suppose if your n is given 2, then you know that current minus n, count minus n is going to be 3. So you just have to go 3 times, like 1, 2 and 3, and you want to delete that. So first loop would be to get the length. Second loop would be to actually reach to that particular node and delete that. This looks okay, but actually it is like order of n, but 2n. I can say that 2 is constant, but still interviewer may expect you to have a good solution. Better solution than this. So first you can maybe say this. You don't have to implement everything. First, when somebody is taking the interview, you can discuss the approach, and then if he is okay with the approach, then only you go ahead and implement. Don't start implementing just after that without discussing anything. No, that's not the correct way, because interviewer may be expecting something else, and then if you end up writing whole bunch of code and then in the end if you say that, okay, I have taken this approach, and then he'll be like, no, I was expecting something better. So is there a better solution? Yes, there is. Let's see that. So the best solution is have a dummy node here. Let's say this is D. So I would denote that with some dummy. So it can hold 0 or whatever it can hold, doesn't matter, but it is a dummy node. And I will say that it is the starting point. So we will have slow and fast pointer initialized to this dummy node. And just after saying that slow and fast, you might have got some idea about this, right? So the whole idea is, if I have been given equal to 2, then I will ask fast pointer to go 2 times. So it will go from dummy node to here, and then it will go here, and it will stop here. So this is the current state. And then I will ask slow and fast to move together. So one loop will be there just to ask this fast to go these many times. So it will go from there to here, and then we will break this loop. So this loop is going to execute from 0 to n minus 1 time. And there will be another loop after that. We will ask like this fast should reach the end. So fast will go from here to here, and then slow will come here. So In this loop, we will say slow is equal to slow next and fast is equal to fast next. And as they will be moving together, by the time f is actually reaching here, your slow pointer would be actually reaching here. Now you might be saying that actually you want to delete this, then what is this slow pointer doing here? This is not correct. Actually, you want to delete this. Actually, this is your second from the back. But the point is, you cannot just delete that. You have to connect this 3 from here, right? So in order to connect this 3, you have to be on 3. So yeah, now slow is here, fast is here, and slow's next is going to get deleted. So this is very simple. Once you have reached to this, after this loop, you will break this because you have reached till the end, and slow is here, fast is here. Then you will break this loop and come out of this loop and just do one thing. Slow's next is equal to slow's next next. Pay attention because people get confused a lot. See, I want to point this is a node, okay? And this is the next area of this. So I'm telling that this is some area. Now I was pointing to 4, but now I want to point to 5. So how would I do that? I would say slow's next, meaning this area. So slow's next is this area. I want to initialize with slow's next, which is this guy, is next, which is this guy. So this is actually going here, meaning now you are making the connection. So slow's next is 4, 4's next is actually 5. So this is n. Okay. So I'm saying that slow's next is going to be 5 instead of 4. Got it? So we have seen with this dummy node also. Now I would like to share that solution which doesn't require any dummy. What is this dummy? Actually, no dummy variable. So the question is, are you ready? Yes, you are ready. So the idea is we'll keep slow and fast here itself. We'll not take any dummy or stuff. We'll say that we'll start from here and then see how it goes. We were taking that dummy to avoid one particular situation, which was going ahead of this, meaning going to some null node. But now we won't be afraid of that. We would actually go there. So we'll do the same thing again. If your n is equal to 2, then in that case, fast will go 2 times, 1 and 2. Fast will stand here, and then we will keep on moving fast and slow one by one together. So till fast is actually getting here. So if fast will get here, then you are standing here. Correct, right? And you wanted to delete this. So still you have this option. The corner case here is that if you want to delete this guy, then you would say, I want to delete 5 from back. So this is going to be 5. So if your fast is standing here and you want to say 5, so it will go like 1, 2, 3, 4, and it will go to null. Now the point is, you said 5, that's why your first loop went till 5 and fast actually reached to null. Now fast is actually null. So after coming out this loop, you will check if fast have reached null in that case, and in that only case, you want to delete the head itself. So in that case, it is very simple. Just return this guy, meaning heads next. Simple, right? So this is the only corner case with this approach. Otherwise, go with the dummy one. If you don't want dummy, then take this extra if. So I explained you, right? Like there will be 2 loop. In one loop, you will go like whatever this number is, you will go till that many time and increment just fast. And then in second loop, you will increment fast and slow together till you reaches the end. So this step and this step is same. Here you will just have one simple condition. If fast have reached null, if it is equal to null after this first loop. If that is the case, then just return the fast, heads next. Let's see how we'll code this. So this is your function. We have this head here and n is passed inside function. We are initializing fast as head and slow as head. There is no dummy here. You will not find any dummy here. So fast and slow both are initialized with head. Now see, I'm going these many times. So I'm saying fast run for these many times. So I'm talking about this loop. Okay. So it will go ahead n times. And then this is that check I was talking about. So if fast is not there, meaning it is null. In that case, just return heads next. Otherwise, it is very simple. Keep looping till fast reaches the end. And see, fast is equal to fast next and slow is equal to slows next. So we are saying that both are going one by one, and this is the second loop. And in the end, as I said, slows next is equal to slows next next, and just return head. So if you like the content, don't forget to hit the like button, guys, and do subscribe this channel if you want more content like this. Thanks for watching, guys. Bye bye.